Yes, we're in. Ladies and gentlemen, welcome to the recording of sections 1.4 and 1.5, brought to you by room, what am I in, 365? I don't even remember what room I'm in. I just lost my momentum there. You lost all that great dramatic intro. Yesterday we did sum and difference. Let's recap. So we did F plus G. Let's do red. F plus G was sum. G plus F. It's all on the screen, right? Difference, F minus G, G minus F. And product, G times F, F times G. Quotient, F over G, G over F. That was yesterday. Cool? Next page. Now, what we got to here was, in the case of the new function, I think I misspoke yesterday. Let's consider this. In the case of the domain of the new function, you have to consider the domain of the two originals, consider them, but ultimately you look at the domain of the composite function. So consider, that means there's two functions. Consider the domains of the original. But ultimately you defer to the domain of the composite function. I can do this. I can write smaller. I can make it fit. Bam. That's what it says. Let me put some context on that kind of thing. We're going to do all the domains. So for A, B, C, and D, we'll do the domains. So F plus G that we did yesterday. And I did this, right? So I'm catching up with you. This doesn't look familiar, unfamiliar. So I said x cubed. Poop. I'll go quick because you've done this. Plus radical x plus 1. The domain of both of those, pretty easy. We know the domain of the original f of x is all real. And then the domain of g of x is negative 1 to 0. If it's mathematical fire you're feeling, Taylor, don't let it go. If it's mathematical fire you feel, I want you to keep on to it. Bring it on. The domain of the composite is both of these. You know, it's the composite. Ultimately, you look at the composite function, say, what's its domain? It's restricted by the radical. So we put in, can't be negative 1, less than negative 1. I got that from setting, x plus 1 greater than or equal to 0. We've done this before, so I'm just writing them in. F minus g was x cubed minus the radical x plus 1. No big deal. Come on, expand a little guy. The domain on that one, same. Same issue. Radicals keep us from being anything that would cause this internal chunk to be less than 0. So we want to make sure that works. All right, negative 1 to infinity. Okay, good. F times g, same, same, same. More of the same. Domain, the same. Okay. You ready for some variety, though? Are you bored with that? Jess and I got to hang with Dad this morning.
How was that?
Awesome. I always enjoyed hanging with your dad. I miss being next door to him and hearing every word he said at Prairie View. Every word. It was like it was paper between us. So F and G, x cubed, radical, x plus 1. Now, I'm going to have to start hunting some of you down. You guys are off and wandering. If you've checked out before this, get back over here. Start looking over here. The radical stuff, you guys know I need to be x plus 1 has to be greater. That's the innards of this. Oh, poop. I don't want to erase. I want to highlight. Don't erase. Highlight. There you go. There we go. See that? That little piece right there. has to be greater than or equal to 0. That means x is greater than or equal to -1. Okay. The denominator, I know it's the radical, but you better do it also. You got to say radical x plus 1 cannot be equal to 0. Square both sides, you get ba-da-ba-ba-ba. Do you know that song? Are you loving it? Not equal to -1. This is different than the domains I just wrote because, yes, the radical says x greater than or equal to -1. But the denominator will not allow the 0 that I can get with a radical, so that's why x cannot be -1. So it's parenthesis -1 to infinity this time. Whew. That's awesome. Okay, onward. Composite functions. There's some notes here about f and g. That is funny. Yeah. I don't mean to say anything that sounds mildly like I'm swearing, but the functions f and g, say that carefully, the domain of f and g consist of all inputs that map to outputs in the relation. Okay. No big deal. It's the same notation we had before. I'm not going to elaborate on that right now. We'll get to that another time. Let me show you this part. There is some nicknames we got to thread in here. This little piece, right, you know what I'm saying? These f, g of x, all those parentheses and things overflowing. A long time ago, well, maybe last year, you guys learned how to deal with this, and it was, you had to call this something. This was f of g of x is the first one. F of g of x. That's what this is called. I'll underline the ofs or highlight the ofs. That wasn't so good. Need a smaller highlighter. Just underline them. F of g of x. That's what that's called. Seriously. This one here, this one's called g of f of x. And this one's called Sydney of Betsy of 3. No, that's not the name of it. F of G of 3. Weird, huh? I think we got them all. That's just terminology. Now we're going to mess with them, and this really is going to play with our minds. The key is making composite functions and building them. I have something that'll help, I think, that I'll let you guys look at. If you have issues with composite functions, you come talk to me. I'll show you where it's at. There's some things to learn. First one, A. A. Let's do A. I got some, oops, put that back in. F of g of x is our first goal. Let's call this I. I? Let's do that for I. We'll call I g of f of x. And I think the last one's f of g of 3. Where I'm getting this from is I'm going to call this the I. Okay. We're going to test all three of these dudes. F of g of 3. There. Okay. Here's how they work. F of g of x means you take all of g of x, whatever g of x is, and you put it into f of x wherever there is an x. So the idea of a function, this little x inside here actually just means whatever you put in those parentheses in that function f, whatever you put inside there, you must also put in for all x's inside that function there. And likewise, if I do all the x's in g, whatever I put inside those parentheses there next to the g, that must also go in for the x's inside its function. So I'm going to write f of g of x means I use f as my framework, like the function f, 2x, but I'm not going to use an x, I'm going to use 2 parentheses, because I got to leave room to put in all the g of x in that space right there where x used to be. So I got to put 3x squared plus 7x in there, because I shoved g of x inside f of x, therefore I must put g of x in where x used to be in that function. Threw it in there. Next, g of f of x. You got g as your framework, so you got 3 parentheses squared plus 7 parentheses. I'm putting f of x in this time. Dude. Here, here, here. So whatever f of x is, 2x, no big deal. I just throw it in here. There's a little 2x. There's a little 2x. Both cases, I'm not actually done, but I just want you to see the substitution taking place. Okay, so I'm gonna simplify those. Both of those simplify, and I should. So I distribute the 2, and actually you won't really be able to figure out the domain until you do simplify. So I got 6x squared plus 14x. Yeah, looking good. And then the second one should simplify to, now I know this little 2x squared makes 2x quantity squared is 4x squared times 3 is 12x squared plus 14x. You guys check my work. Oops. Plus 14x. Oh, that looks good. That's just the simplifying. What do you think? Is composing coming together okay? You've done this before. Ringing a bell, putting a function inside another. F of g of 3, let me show you my favorite way to tackle this. I go find g of 3. When it's a value, g of 3 is a number. When you have a value you put in for x, you're going to get out a number. So g of 3, I go find that first. That would mean 3 times 3 squared plus 7 times 3. So that's 3 times 9 plus 21. So 3 times 9 is 27 plus 21. I get 48. That's g of 3. So that's when I have a value for x actually inside my internal function. I find the value of it because I take that thing and I'm going to put it inside f now. 48's going in. So f of x is 2 times 48. And that'll give me 96. And I'm done. The only thing though, it does ask for domain. Let's do it in green. Domain, it's a polynomial, all real. You don't like that? How many times? 4, 5, 6, 7, 8, 9. Was that 8 or 9? I think it was 8 clicks. I'm going to go for a record today. 8 clicks. Like, what's the most number of clicks I have to get? Thanks. Domain all reals. It's a polynomial. All polynomials have all real domains. All polynomials have all real domains. Domain is all real. Domain is all real. Let's move on. Preguntas? Next, B. B, this is where we earn our money. The big bucks. So I think we're going to go for I, f of g of x. Going to get that one. Let's do it. F of g of x. F is the framework. So that's 2. Instead of 2 to the x, it's 2 to the parenthesis. And inside that parenthesis, radical x plus 1. Not cool? Shall I scroll over? Can you see F and G? I'll tell you what I think of G.